Hello everyone, let us discuss one of the exercise problems. So the problem goes to determine the amount of magnetite. The formula is Fe3O4. An impure sample of this amount, 1.5419, is dissolved in concentrated HCl, giving a mixture of iron plus 2 and iron plus 3 because magnetite is a mixture of ferrous and ferric ion. So it was oxidized. The ferrous ion is oxidized to Fe3 to ferric and then precipitated as ferric hydroxide, filtered, rinsed, ignited. So the ferric hydroxide, when ignited, will transform into ferric oxide. So this is now the mass of ferric oxide that was collected. The problem is to calculate the percent Fe3O4 magnetite in the sample. So you will collect the ferric oxide and report it as Fe3O4. When solving problems, it helps to visualize the process. So this is a sample. I-illustrate natin that the sample consists of a mixture of ferrous and ferric. Okay, so this is the magnetite sample. Of course, according to the uh, explained procedure, it was dissolved, etc., and eventually collected as ferric oxide precipitate. Ferric oxide, Fe2O3. So I presented the ferric oxide in this manner. You have 2 units of iron and 3 units of oxygen because the formula is Fe2O3. We can collect uh, the precipitate and determine its mass. Then, from mass, we convert it to moles or millimoles. So in this case, since I represented this by circles, so each circle would represent 1 millimole. So how many circles are there? There are 9 circles, so that will give me 9 millimoles. So each circle here represents a millimole. So that is in my illustration. Now, okay, so this is mass. You can get mass, convert it to millimoles. And then from millimoles of ferric oxide, we can determine the millimoles of iron. Okay, since there are 2 iron units in 1 unit of ferric oxide, our factor here is 2 times 2. So 9 times 2, that will give me 18 millimoles of iron, ferric iron. Now, since we need to report it as Fe3O4 magnetite, okay, so Fe3O4, ito yung representation ko ng magnetite. Isipin nyo, uh, ilang iron units in one magnetite? Tatlo, tatlo, tatlo. So itong 18 na ferric ions, ilang magnetite ang kanyang mapo-form? Okay? So, divided by 3. So, this 18 millimoles of iron will result in the formation um, of ilan? 6 na magnetite molecules. Of course, as I was mentioning earlier, magnetite is a mixture of ferrous and ferric. Ito, hindi natin talaga in-isolate. We isolated etong ferric oxide, not this. So, we just translate the number of iron that we obtained from this precipitate into magnetite. Ito hindi natin in-isolate. Ito ang ating na-isolate. So we report the isolated ferric oxide ion as magnetite. Okay? Since, as I was saying earlier, tatlong iron units per magnetite, etong 18 millimoles of iron will give us ilan? 6 na magnetite units. So, ang ating factor na naman dito is divided by 3 to give us 9 millimoles of Fe3O4. Okay, so we proceed. Yes, this is the mass of the precipitate na ferric oxide, Fe2O3. We get the mole by dividing it by its molecular weight. So from mass in grams, we convert it to mole of ferric oxide. Ito is the factor that will convert it to moles of ferric ion. Okay, times 2. Then, as I was explaining earlier, each Fe3O4 will need 3 iron units, so you need to divide it by 3. And of course, to convert it to ferric, Fe3O4 magnetite, you need to um, multiply it by the molecular weight of Fe3O4 to give you uh, from grams of ferric oxide, this is reported as grams of magnetite. Okay? So, ito na yung where you place the values, molecular weight, the factor, molecular weight, the factor, and this 0.8525 grams of ferric oxide will translate to 0.82405 grams of magnetite. Ngayon, yung problem is percentage. Next slide is, so ito na yung translation from ferric oxide to magnetite. We need to get the percentage of magnetite in the sample times 100, this gives us 53.44%. Take note, ilang significant figures? 4. Kasi yung given sa atin, ito, 4. At ito, 5. Since we report it according to the factor that contains the least number of significant figures. So, adto ta sa gamay nga significant figure, 4.